Every differentiation rule has a corresponding integration rule. For instance, the chain rule for differentiation corresponds to the substitution rule for integration, and the product rule for differentiation corresponds to the integration rule called integration by parts. That's what we'll be looking at in this video. To use integration by parts, we'll use this setup. We have the integral of u dv equals uv minus the integral of v du. Notice we have the integral of a product, and then we're just rewriting it in a way that will be easier to integrate. Up first, the integral of x cosine x dx. The first thing we want to do is figure out what u and dv are. We want to break this into parts, x and cosine x dx. The part that we want u to be is going to be the part that will be more simplified once we take its derivative. For example, if we take the derivative of x, we get 1, which does get simpler. If we take the derivative of cosine x, we get negative sine x, which isn't much simpler. So let's let u be x and dv cosine x dx. Now coming over here, we want to take the derivative of u to find du. The derivative of x is 1 dx, or just dx. And then looking at the dv, we actually want to integrate that part. So the integral of cosine x is sine x. Now we'll rewrite the original integral using this rule. We have u, which is x, times v, which we found to be sine x, minus the integral of v, which we found to be sine x, du, which we found to be dx. From here, we can integrate. We'll bring down the x sine x and the minus sign. The integral of sine x is negative cosine x, so we'll make that plus cosine x. And now we just need to add on the plus c, and we've got our answer. In our next example, let's start by identifying u and dv. Recall that we want u to be the part that when we differentiate, it gets simpler. For example, if we take the derivative of t, we simply get 1 dt. That does get simpler, so let's let u be t. And dv will be e raised to the 2t dt. Then over here, let's take the derivative of u to get du. The derivative of t is 1 dt, or just dt. And then focusing on dv, we actually need to integrate dv to find v. The integral of e to the 2t is 1/2 e to the 2t. Now we can rewrite the original integral using parts. As a reminder, here's the formula. U is t. V we found to be 1/2 e to the 2t minus the integral of v, which we found to be 1/2 e to the 2t du, which we found to be dt. We can rearrange that first term a little bit. 1/2 t e to the 2t minus, I'm going to pull the 1/2 out of the integral, and now we're looking at the integral of e to the 2t dt. We actually already did that over here. That is 1/2 e to the 2t. And we need to not forget that plus c. Finally, we can simplify a tiny bit. Copy that first term. Negative 1/2 times 1/2 is negative 1/4 e to the 2t plus c.